Welcome back to Area Diesel Service. So today we have a new and interesting and exciting collaborative effort with fellow YouTube content creators, CNC Equipment. Please jump over there, check them out, tell them that we sent you. I think you will find some very interesting and entertaining content on their channel. They are YouTube's premier heavy equipment repair and rebuild type of channel, and they're always getting into some shenanigans over there. A lot of good high quality repair. So if you're looking for dozer content or heavy equipment content, or if you're looking for a high quality machine, that's the place to go, right? These boys are masters of their craft and friends of Area Diesel Service. We have an injection pump inside of this box. It comes off of a John Deere 450G. According to the interwebs, somewhere in the 87 to 1995 era. This is a John Deere powered John Deere bulldozer, right? No big surprise, they run their own engines. It is a 4045T, which was formerly the 276 cubic inch 4-cylinder John Deere diesel engine. That is 4.5 liters for those of you on the logical system, and it's checking in at 73 horsepower and weighing in at 16,000 pounds. She's a little bit more of a baby bulldozer. The story, as I understand it, this is like many others. It was an auction score.
350. So time with Big Mac is her.
Complaints were leaks, specifically leaks engine oil. The governed speeds are incorrect. Low idle, it's down where it's barely running, couple 300 RPMs where it ought to be 600 or 800, and high idle, we're only getting 1700, and we ought to be about 2100. Something wonky in the gov'na.
Hello, gov'na.
The gov'na?
Hello, gov'na.
Holy crap, it's real!
Couple of things going on, right? We got a leaker and we got a fuel metering issue or a governor issue, or the schmoo has infiltrated this pump. This is a new model to bring to the YouTube world. This is a Stanadyne pump, of which you have seen many, but this particular pump is supposed to be a DB4. We'll get into a little bit of what that means, or at least what little of it I know, and then Corey in the back will really show you what DB4 is and how it's different from what you've seen us do before. So first thing we're going to do is open her up, get her out, and we'll see what we've got. Initial assessment, almost didn't make it here, and the boys at CNC are always doing a fine job of packaging. The test that we recommend is the wiggle test. If it wiggles in the box, it'll probably come out of the box. This one got softened up with a little bit of schmoo, and you can see about come out the bottom. Do your best. I know it's hard to get them packed up proper, but they're hard enough to repair and find parts for sometimes. So if we can avoid any additional damage out of the shipping world, it would be helpful. They got her sealed up good, got some good tape on her. They even put some staples in it. Pig mat. Nailed it. I forgot. Yeah. I couldn't figure out why these were Cummins beige and why they'd be with a DB4, but then I remember we have 2 episodes. We'll bring these back. Stay tuned. Initial inspection. Return connector is missing, not uncommon. See where it's been whoppered on that fitting. I'm going to say someone has been here before us. It looks like this tag has been transplanted. It looks like they popped the rivets off and then put it back on with a 6-pound sledgehammer. Paint job is not factory. The seal paint is purple, which is somewhat unique. Shops put that on there so they can tell if someone has been inside the pump behind them. It's been beat to death back here on the housing. Nothing we haven't seen before, right? Clint questioned why the timing window was between the block and the pump, and that may or may not be the correct side. A lot of the DB4, this is a DB4 style pump, a lot of them don't rely on the timing window. And he also questioned if the throttle lever was on the correct side of the pump. And I can't answer that off the top of my head, but we can certainly look it up and tell you about it. There is a weep hole in the housing here that resides between two seals on the shaft. And they're conceptually the same as the umbrella seals in the preceding style, the preceding technology, but these are more of a lip seal, one keeping engine oil in the engine and one keeping diesel fuel in the pump. So if you're making oil, you could have a situation here. If you're getting either of those fluids out of this weep hole, you've got an issue in the seal. And then the idling or the engine speed issue remains to be determined. This is John Deere part number RE500616. That is how John Deere identifies and refers to this component. We call it a DB4 style pump. That's a Stanadyne or a Master pump designation. Specifically a DB4 429-5414 B version of a D style pump. So DB4. The 4 indicating 4 roller or 4 pumping elements. The second 4 indicating that it services a 4-cylinder engine. You can see 4 injector line ports here. 29 is short for 290 thousandths diameter pumping elements. So that tells you how big of a bite that pumping element can take. And the dash 5414 is the specific calibration specification and bill of materials for this arrangement of this specific pump. There's all kinds of variations of DB4s, electric shutoff, manual shutoff, lever here, lever there, return connecting. Some of them reside horizontally, some of them vertically. So there's all kinds of different arrangements, all kinds of different components inside, but conceptually they all operate the same. And the DB4 is not dramatically different than the other Master pumps you've seen us do. Rotary injection pump, engine driven here at half of engine speed, camshaft speed, fuel inlet here. There is a vane style pump in the back of it that is providing pump housing pressure and pressure to the head and rotor. There is a set of weights that centrifugal force throws them further and further out the higher they go. They operate on some magic levers and linkages that pull some rods and valves, and that's how we govern engine speed. Very, very similar to the others that you've seen us do. This particular unit, a little bit different in the advanced department. So this is a servo advance, and Corey will get into what that means because I really don't know, but it is different than just a speed and pressure mechanical advance. So there's some additional pistons and magic happening in here, not wildly different than what you've seen before. So we will write this thing up. We'll start a service order in the fuel injection shop. Corey will be your technician on this pump, and we will follow through the process. We will do the full feature director's cut, and we will find out what is going on with this pump, and we'll let you see if we can fix it. So we'll bring you back.
Hi everybody, I got this DB4 here from our good friends over at CNC. Got this John Deere DB4 pump. According to my Stanadyne, it goes on a 450G crawler. Pretty basic. This particular one, we've never done a DB4 before, so it'll be something a little new for the channel. I've done DB4s are kind of a staple right now, so I've done thousands of DB4s, DB2s. They're not a ton different than regular DBG. It's just a little different design. These actually do have 4 rollers, which I believe Kurt maybe mentioned that up front. That'll be a little different whenever we go to build it back, but for right now, not really too big of an issue. This one here does not have a cold start solenoid, so that's makes it a little easier. It does have a servo advance, which I'll explain that more once we go to build it back. Other than that, low idle and top cover solenoid. Guys over at CNC were concerned the legitimacy of this pump for this particular engine. There's 2 major concerns. One of them was he thought that the linkage was weird. He thought maybe the lever should be on this side actually. And then he was also wondering about the side cover, because on a normal Stanadyne pump, you look through the side cover to do your timing mark, or on DB4s, that's not really the case. They almost never have an internal timing mark. They almost always have an external timing mark here on the flange. The one major difference between DB4s and DB2s in comparison to like a DM pump or DBG is how they're timed. DB4s, the drive shaft here is retained on the inside through a snap ring. So, and it's also a keyed shaft. Not all DB4s are keyed, but 90% of them are keyed. The pump only goes on one way. Pretty straightforward. Line up the key with the keyway in your gear, stick it on there, bolt it on. But then there's most likely going to be a line on your timing cover, which then the line here on your flange should line up with, and then that will give you your rough static timing. You still might have to tweak it one way or another, but that's the basis of it. The side cover placement doesn't generally matter. On these, it's not uncommon for the timing cover to be on the inside, or if you want to call it the inspection cover. For this instance, I know that he was looking with a mirror to find the timing mark. Well, there isn't probably one. I don't know that for sure. I'll have to look on my test spec, but most likely it doesn't have an internal timing mark. But also with the lever, according to my breakdown, this lever is on the correct side. It is the correct housing. My professional opinion, this pump is exactly how it should be. I'm going to get this cleaned up, get it blasted, get all the paint off of it, and then we will start ripping her down. And I got a new camera arm, so hopefully I won't screw up the video too bad. Man, this mounting O-ring is stuck in there. Most of the time these just come right out. I don't really know why this one's being such a pain. It looks like it's an aftermarket O-ring, which isn't necessarily unheard of. Okay, that'll blast off. So, I think we're pretty well. I'm going to take that off. There we go. That there is just a tamper-proof cap, so people can't get into their pumps, is all that is. I'll rip the tag off. Okay, it is ready to go. Okay, so I got the pump all cleaned up here, nice and shiny. Paint came off nicely and easy, so that was good. This here is just a tamper-proof cap that just peels off. So that there is your torque screw. Start just like a DBG, start from the top, work your way through. This is your low idle screw here. Top cover bolts out. This just holds that little plastic cap. There we go. That came right off. So this is your shut-off solenoid, which it works here on your metering valve arm, just like a shut-off clip does. Power goes in, sucks it in to run, shut off, push the shut off. Pretty simple. Top cover O-ring. Luckily this pump looks pretty clean on the inside, so that's a good sign. Throttle shaft clip just holds everything together. There we go. Throttle lever. He has a little bit of gunk in here, but we'll see how bad it gets the further we go down. I know also he said that it was leaking out the weep hole. Generally means that the seals are bad, which is a very common problem on these DB4s. All this is all the same from a DBG. Nothing's changed here. Governor spring, idle spring. Most of the time, yep, still same with this one. So on DB4s, generally you can't get this metering valve arm to come off of the metering valve pin because of this throttle bushing. So I gotta wait till I get further down. I gotta twist the head around, and that moves that over just a little bit to where I can pop that off. This little locking plate has little teeth on it that goes into your teeth here on your end cone. That just keeps the end cone from turning. Also, that's where I read my transfer pressure out of, so I had to take it out anyway. So, obviously this is your inlet coming in through your end cone. Return comes out the top. So this is your transfer pump end. This is just a screen. This is your transfer pressure regulator. It's same concept, just different design from a DBG. Has your adjusting screw, has a spring, has a piston in there. The tighter you go down, the more transfer pressure you make. Just like on DBGs, these pistons wear out almost always. Which this one isn't terrible, but it definitely has some wear on it. I don't know. But it basically gets wear right here on the bottom, and normally it'll come up the sides of it. There's a little O-ring in here that you got to poke out. That O-ring there was in the bottom of this. I leave that roll pin in there because there's just no real need to take it apart. Got your liner and blades, just like on the DBG. That has some wear to it. Not the worst I've ever seen though. You can see all the crud in there. Just your head bolts. Just another plug there. Get this washer off of here. We'll take the inspection cover off. That away. Take our pivot shaft out. Got our pivot shaft here, which it looks pretty good, just a little dirty. This here is your light load capsule. So you have, this is what's called a servo advance rather than like a speed advance or auto advance. Transfer pressure is pushing on this side, pushing the piston this way. So you have transfer pressure on this end, and you have metered pressure on this end, which is being regulated from your metering valve. Transfer pressure, the faster you go, the more pressure you make, so the more it's going to try and force it this way. This has two springs in here. One spring is pushing on the servo, and then another spring is for your light load. So as your metered pressure goes up and down, it will then change the amount of pressure that's on this end, which will let this piston move forward and back more or less. So that's why it's called a light load advance, because it's all dependent on your amount of load that you have on the engine. Nope, I might have to go get my side. Oh, there it went. Okay. Don't look too bad. So also this is the old style adjuster. This part here, you can see it has two flats here. So this big part goes in or out, which changes the pressure on my light load spring. And then you have this inner adjuster that changes your speed advance. So you have a speed advance setting, and then you have a light load advance setting. Two different things. They both kind of work together, but also they work opposite. This here is your light load orifice. Again, helps regulate your advance. Regulates the pressure going through there. There's round style one, which is the old style. And there's a hex style one, that's the newer style. And these round ones, they can be kind of a pain. So again, this is just fuel goes through. Then there's a little bitty orifice right here. That's why it's called light load orifice. O-ring down in here, which actually that O-ring there, I can tell that this has been rebuilt before. A, that's an aftermarket O-ring, and B, that's wrong. It's not the right O-ring for that orifice. So you can kind of see here, this is your speed advance spring, which on the old style that's kind of held in there. And there's a piston. You can see that slid into that piston there, and whenever I push on that, that whole thing moves, which then you can see that move in or out. So that is your light load section. This is your speed advance spring. Which I'm just going to leave that in there for right now. This is the right bit. This here is your cold advance, cold start piston. This particular pump doesn't have the solenoid, so this doesn't go in or out. If it did have the solenoid, then this piston here would move in or out depending on if the solenoid was on or not, and that basically just gives you normally 5 to 7 degrees of advance during a cold start situation. This helps your engine run smoother. But like I said, this, it moves, so I'm not too worried about it. It'll clean up later. O-ring off. Now it has a cam pin in here, which hopefully it'll come out easily. It looks like it will. I would say this was definitely, so a lot of DMs, some like international DBGs will have a cam pin. That's your servo, which I'll explain that here in a second. They'll have cam pins, but they actually have a hole in them so you can stick something in, where this just has this little point on it. Terrible design. They're an absolute monster to get out sometimes. Whenever this moves back and forth, that changes the cam. So that changes your timing. No different than a regular DBG. Head locator screw, has a little check ball in it. Okay. So now I'm getting real close. Well, at least they put the right O-ring on this side. Also, this housing here is not sleeved. So most likely the housing is, the housing is definitely worn out. So these older style ones with these older style advances, these housings generally are not sleeved with a steel sleeve. So this piston is wearing inside that aluminum bore, and they just wear out. It's not uncommon. We actually can sleeve these here ourselves. We put an anodized aluminum sleeve in there, so it's a lot harder than this. And then we just grind down the stock piston to an undersize to fit the sleeve, and it's good as new. And really, it's better than this. I'll take that out too. This is just a cold start plug. Get this metering valve out. Okay. So now that head has moved that just a little bit. I turned it counterclockwise, so now I can get this governor arm out. So now I can actually unhook it, pull the metering valve out. It doesn't look too bad. I might actually, yeah, I'll be able to reuse that. So that's good. So at least there's some good parts in here. It's not completely worn out, which doesn't really surprise me since it does seem like it has been rebuilt before. You know, we don't really know what all parts they changed. This here is a vent screw, which is the same on a DB2 Automotive, which I know we've done a couple videos about. So basically this just regulates your return fuel. You can see there's a little bitty wire sticking out the top. You can just barely kind of see it. It's right there. Anyways, there's different size wires, you know, smaller wire, more return, bigger wire, less return. Simple concept. Now I can punch this head out, just like that. that one actually came out very easy. Have your gov'na weights that sit in here, just like a DBG does. Again, a lot of this is really all the same. Your weights, you got your thrust sleeve, your thrust washer. I can take this gov'na arm out now. No different than DBG. We'll get to that in a second. Drive shaft. So again, that is all retained in there, so it cannot, well, it can come out that way, but if it's coming out this way, you got problems. So it's not supposed to. It's supposed to go in through the inside of the pump. Have a little snap ring there. Has a spring washer, wavy washer, thrust washer, thrust bearing. So you guys know some terminology there. This drive shaft has probably been replaced before because it actually looks really good. No concern there at all. Put that back. So now I'll peel this. This is a retaining ring here that holds these half moon plates. Now on these ones here, these plates have holes in it. So on these DB4s, a lot of times, especially the ones with the holes, they have to go back in the way they came out. You can't flip them over, can't move them around. If you do that, then your transfer pressure won't work. So that slides off of there. There's an end cone O-ring in there, which that is the style we don't even use because they're not very good. Head O-ring. So you can see there's definitely some schmoo on there, if you quote Kurt on that. Again, not terrible. It'll clean up over lunch very easily. After lunch, it'll probably be spotless. Cam looks okay. Don't see any major concerns with that. The lobes look fine. Okay, so this is where it's different. You have 4 rollers. There's also 4 pumping plungers. There's 2 long ones and 2 short ones. These rollers also, not the rollers, the shoes have numbers on them, which is normally right here on the end. It's too small, you won't be able to see it. Anyways, so depending on what shoes you have in here also determines how much fuel you can get. So it's not like a DBG where you have different leaf spring sizes. On these ones, the leaf springs are all the same, but the shoes are different sizes. So if you're looking for more fuel out of a DB4, you got to go to a bigger shoe rather than a different leaf spring. So see there, you have 2 long plungers here, 2 short plungers there. Which basically you just got to match long to long and short to short. Take our delivery valve out. This is just the delivery valve screw. We'll see if this will come out. Now we have our delivery valve. There we go. Yep, it came out. So that's good. Just a few little gentle taps. You have your delivery valve there. It's not really any different. It's just a different shape. Other than that, it does the same thing as a DBG. It has some wear to it, so I'm going to replace it, which is not uncommon. So this weight cage here is held on to the rotor through these clips. There's cushions underneath there, which normally I don't normally replace them just because normally they don't necessarily go bad. If for some reason I have to change the weight cage or I have to change these clips, then I'll replace the cushions, but normally it's just not necessary. I don't see a timing mark on here, which I'll double check that on the breakdown. Most likely there's not going to be one on there. They'll leave the leaf springs on there. There's no reason to take them off. Okay, now basically all I got is to take this bearing. Aha! I see his problem. One of the bigger concerns, like I said before earlier in the video, was that it was leaking out the weep hole, which Kurt had told me that it was leaking oil out of the weep hole, which is unusual. Normally it leaks fuel. Well, I don't know. Yep, you can see it right in there. See right there? That oil seal is flipped down. It's busted. For whatever reason, you can see it sticking out through the hole there. I don't know why this seal did that, but for some reason, it failed. I would assume, this is just my assumption, that most likely they did this whenever they installed the drive shaft. So what I have is the seal sleeve. So that goes on here like this, and then that goes through here like this, and that's what keeps that from happening. So most likely, whoever did this before did not have one of these. So whenever they went to push this through, I bet you this, most likely one of these, part of the tang here, or I guess technically the side, probably caught that seal, or they put it in at an angle, it caught it and it pulled it down, and that's what created the issue. So I would say most likely, through my professional opinion, it was all builder error that caused this problem, because I don't think I've never seen that particular thing happen before. And like I said, normally if anything you mess up the fuel seal is what normally goes bad. So I gotta get my puller. We'll pull that out. Okay, so this here's my seal puller. Goes in here like this. It's all the way down. Tighten this down. I will say it is kind of nice whenever you do one of these and you actually do find a problem. You know, it's kind of a pain sometimes whenever you tear something down. It's like, well, I didn't really find anything wrong with it, you know. I'm going to replace the seals and everything anyway, but you don't really have that smoking gun that it's like, yeah, okay, that is what caused it to fail. Where this one here, we know for sure that is the reason why it was leaking oil. All because of that one seal. So now that housing there is all done. Which I said, we're going to replace this housing anyway with one that we've remanned. So that's not too bad, but I mean, it definitely isn't a bad housing. It's definitely fixable for sure. So you have bearing, oil seal, fuel seal. This is just a roller bearing. Has all them, or I guess it's probably more like a needle bearing, regardless. Comes in the kit anyway, and there you go. There is that bad seal. You can see that it is flipped up there. You know, it goes into the pump like this. So whenever they, like I said, whenever they brought that drive shaft in, they probably caught it, and that's what brought that down, and that's why it was leaking oil through there. And we don't even use these fuel seals. That they're not as reliable as a regular lip seal, so that's definitely an aftermarket kit for sure. Like I said, they're really not that much different than a DBG. They're just designed a little differently, but overall it's the same concept. Same way whenever I go to build it. Overall, you know, it's definitely more different going to build it. Let's put it that way, in comparison to like a DBG or a DB2 even. Just because you have to set the head differently and things like that. The advance is different. But it's nothing that we can't handle. Like I said, these DB4s, DB2s are kind of our bread and butter right now. It's kind of a, you know, just a sign of the times, because back whenever I started doing these, you know, 7-8 years ago, a lot of the DBGs were like primary bread and butter, did hundreds of them. Well, now it's slowly shifted to where now the DB2s, the DB4s are primary We do some DMs, and we still do a lot of DBGs, don't get me wrong, we still do a lot of them. But these are definitely coming into the market now to where they're wearing out, and there's more machines out there. A lot of these have been doing a lot of construction pumps, so crawlers, loaders, you know, backhoes, excavators, stuff like that, that these are very common on. And they do have these on regular tractors as well. Anyways, I'll get this cleaned up, and then I'll get parts ordered for it, and we'll put her back together and go from there. But as of right now, I think we definitely found the problem, so I'm happy with that. I got everything laid out here. As you can see, it cleaned up very well. There were still a couple parts I had to buff, but for the most part, it cleaned up pretty good. I ordered my parts. This little pile here was the parts that I had to replace. Obviously the housing, advanced piston, stuff like that. This is our reman housing, brand new parts here. And this is one of our reman advanced pistons. You can see the little bit of wear there on that piston, especially like up here and on this side right here. You can kind of see around that hole especially. And this here is one that we have ground down, basically brand new. So it's undersized compared to a stock piston, so a brand new one. But it fits our sleeves that we put in here, which I will show you. Here we go. So this is our housing that we remanned. Here's a good comparison here. This is the stock housing, his original housing. There's no sleeve here. It's just a piston inside the aluminum casting. This one here has our sleeve in there. It's basically an anodized aluminum sleeve. So it's harder than a normal just aluminum sleeve. And it's honed out straight, all the good stuff. So then our piston will basically just slide right in here like this. And now that is a perfect fit, and it should work perfectly like a brand new housing. So that's kind of something we've recently started to do. But as you can see, this should be a perfect, and you can see that it is identical to his original housing. So I got this number off of the breakdown for the pump, so I know that this is the correct number housing for this pump, and it's identical. So his concerns that the housing might be wrong were just not the case. There's no need for concern because it is the correct housing. So I got all of my new parts here. Got a new delivery valve, new liner and blades. He did not send in this pump with this return fitting in there. I'm assuming it's still connected to his return line, but it's just a check ball fitting, goes in the top cover, so it goes in right here. Every pump has to have one. Got our gasket kit. This is a actual Stanadyne gasket kit, so it's not aftermarket. Got our brand new seals here. So this is the fuel seal and this is the oil seal. And then we got our brand new bearing, which the bearings from Stanadyne already come pre-packed with grease. So I will put all this into our reman housing and do it the correct way so that way it doesn't leak oil out of the weep hole. And then once he gets this back on his engine, it should work perfectly. Gotta grind up that. So that's there as an old timey mark. I gotta grind that off. But that's no big deal. So I will get my seals put in there, and then basically we're starting to build this thing. Got my new seals pressed in, fuel seal, oil seal, brand new bearing. So as you can see, that's what it's supposed to look like, not cut out like the other one was. And then we will build up the head. Got our brand new delivery valve here. Spray with a little juice. Delivery valve, spring, brand new stop. These are just like DBGs. Once I torque this in, hey, it has to be torqued to the right spec, and then once it's torqued in, I gotta make sure it doesn't leak. If it leaks, it could affect my delivery. Okay. Plungers here. Like I said before, we got 4 plungers, 2 longs, 2 shorts. So we got long and long across from each other, which they're nice and free. Now we got 2 shorts across from each other. That one went in nice and free. That one, so did that one. Perfect. These shoes and rollers, I try and make sure that these rollers are free in these shoes. Sometimes they'll get little nicks on them. And they'll get a tight spot. That one there is free now. Nothing a little file can't take care of. Like I said before, there are different numbers of shoes. And I don't know if these are necessarily all the same number. Yeah, they're not. So, which is no big deal. I got 3 -5s and then 1 -10. Which basically, like I said, that just determines your fuel delivery. Which I'll explain a little bit more why there's a different one here in a second. Take our head. I just buffed that up, cleaned it up. Nice and free. Stick this on. Make sure it doesn't leak. Doesn't make no air bubbles. Plungers are stuck out. Absolutely no bubbles at all. So that's good. Sometimes these ones here will leak, and you can just a lot of times if you flip over that stop screw, then they'll quit leaking. But you always got to check that. While I'm at it, I'll put the head O-ring on. Set that off to the side. Now comes the fun part with DB4s. This is my centrality gauge. So, this rotor gets stuck in here, and as you see, as it goes around, it's going to move that dial indicator. And basically what that is checking is that is going to check the distance that each one of these rollers is out. So, between each roller, I can have no more than 4 thousandths on this gauge from the lowest to the highest. Okay, so that is called centrality. And then you also have to check the pairs of rollers to make sure they are within 3 thousandths of each other. So this is the thing with DB4s that you really have to get right, otherwise it can create inconsistencies on the engine. And there's 3 under, about 5 under, And there's about 5 under. Okay. There's 58. Okay, so right now we're off. 53. Okay. So his fuel really isn't set too bad. Right now it's out of spec just because it's not set correctly, but overall it's not terrible. This is where it might take you a couple tries to get this right. You gotta flip them around and stuff like that. Usually doesn't take me too terribly long. Okay. So now, that one there is my 0 point. That one is spot on. That one's about 1.5, 2 under. And that one's about 2 under. So now we'll check this. We should be a lot closer now. That's 58, that's perfect. 58.5, yeah. So as you can see, just by changing that one shoe, and all I did was just flip it over, it brought that one down to where now between the highest and the lowest we're only about 2 thousandths off, which is perfect. Perfectly in spec. Our pairs are within, I think, 0.5 thousandths. So that was an easy one. Not all of them are quite that easy, but there are some that you just stick them in there and they're perfect. So it's not unheard of for it to be like that. If for some reason you have that way too far out, let's say this one is 4 thousandths high, this is our 0, that one let's say is 2 thousandths low, and that one is, 1 thousandths low, whatever. From, let's say, our highest to our lowest is 6 thousandths. Technically speaking, since this one is high, that means it is sticking out further than the rest of these. That means that plunger, or that roller, is going to contact the cam before the rest of them, which, contacting the cam begins the process of injection. So it's when it starts to, as it goes in on the cam, it builds up pressure until it pops off of the delivery valve, goes out the delivery valve through your distributing ports. So if you had one that was way far off, let's say it was really high, and let's say you had a pair that was really high, then that means that that pair is going to start to collapse before the other pair. And that's why that's important, because it's almost like a pre-injection. It's kind of weird. I don't really know how exactly to explain it, but it can also affect your injection timing too, because you have two that are closing before the other two. So that's why they all have to be kind of in sync, because otherwise it just can create problems. We have our rotor here, it's set, so the rollers are set, the stop not leaking, it's also torqued in. We have our cam ring, that's going the correct direction according to our breakdown. Also, this one here, like I talked about originally with the timing window deal, this pump does not have an internal timing mark. That's why the timing window is on the block side, because it physically does not matter. It doesn't matter if it's on this side or if it's on this side, because you're not going to gain anything out of it. There's no lines to line up, none of that. So at this point, it's literally just a inspection window. That's why it doesn't matter what side of the pump it's on. So that's perfect. I like to double check. Yep, that's good. Have our end cone O-ring. Put a little bit of grease on this. We have our rotor retainers. Again, they have to go back in the way that they came out. And then we got our ring goes on there just like that. I like to line up that slot with that hole because that is what this pin goes through. So this pin slides through the liner and into that hole right there. This is our reman liner because the original one that he had was worn out. Stick that in. Got our brand new transfer pump blades. I like to put a little bit of calibration fluid in there. Have our regulator here. We need our piston. We also need this little O-ring here. So we took that O-ring out. We're putting a brand new one back in. There's a groove down in there that actually sits in, so that's why you just gotta stick a pick in there and make sure it's flat down in there. That looks good. Stick our new piston in there, stick our regulating spring, and then our adjuster. I just kind of preset these because then most likely I'll have to adjust it on the stand. That should be pretty close. Have our screen here, it's nice and clean. That just presses on, put that like that. And now we have our end cone. And I just like to put a little bit of grease where that O-ring rides just so it doesn't bunch up. Goes in a little smoother that way. And this just gets hand tight for now. So I gotta torque that in. Okay, line this up. We have our governor weights. Then we have our thrust washer and our thrust sleeve. Make sure they're all in correctly. Like I said, as your pump speeds up, these weights are trying to force this sleeve out, and then that is what pushes on your governor arm. So that sits in there like that. So as the weights come out, this on the pivot shaft, so then it pulls that up, and then it pushes that metering valve forward to shut off. Just like all other Stanadyne pumps. So now this head is ready to go into our housing, but our housing is not quite ready for the head. We have our original drive shaft here. It has a touch of wear here, but I'm not concerned. It's not nearly enough to where I think it'll cause an issue. It still has quite a bit of life left in it. Have our seal sleeve. Now this goes in like this. So originally, like I said, they brought it in like this, but they didn't have this sleeve. So that's what caused that seal to roll. There we go. And that's what caused it to leak oil. We have drive shaft in, so now we got to put in our retainers. So we have our thrust bearing, it's a big clip, thrust washer, spring washer, retaining clip. And it's one of those things, you know, we've seen so far, even before we've got too far in here, that clip is a little loose. We've seen so far that A, the seals have to be in correctly, otherwise it could cause an issue. And B, the head has to be built correctly, otherwise that'll create an issue. So we barely even started on this pump, and we've seen a few different things that if you don't do correctly, you will have problems with your pump. That's better. I just tightened up that clip a little bit. Put the dot to the top. One thing I like to do, check all these holes. Perfect. Put our gov'na arm in there. Got our pivot shaft. Got our new O-rings for your pivot shaft. So now that is pivoting perfectly on that pivot shaft. A little bit of grease on the inside of this housing, and then it will be ready for the head. Dot is to the top. Dot is to the top. Got our cam in. Okay. This is his original metering valve. I looked at it, didn't think that there's nothing wrong with it. There's a very small little shimmer of wear, but still is not going to create any issue. Stick that in. Twist the head so you can get the metering valve on in there. And now I will put my head bolts in. If you put your head bolts in first, then sometimes you can't get that gov'na arm on your metering valve arm. Just like whenever I tore the pump apart, I couldn't get it off because of these throttle bushings. So, got my vent screw here. I said it controls how much return I get. That just goes in the head. Nice and snug. Now, got our head locator screw with the check ball. Check ball is free. Got brand new O-rings on here. Goes in the hole, gets torqued down. Now we will torque down the end cone. So now the head's in there. Now I'll start going for the advance. One thing with these pistons is there is a orifice screw right in this hole here. So I got to take that orifice out because I'm assuming, yes, ours does not have one. It's also one of those things that now I'm going to save his original housing. I'm also going to save his original piston, so that way then I will take them back to our machine shop and they can, again, put a sleeve in his original housing and they can grind down his piston, and voila, now they have a second life. A lot of these parts get harder and harder to find, or they get more and more expensive. So, you know, if there's a way that we can fix something, reuse something, then why not? It's kind of the way that it has to be nowadays because of just availability. So I stuck my cam pin in here. That goes through the piston into the cam. So now that is controlling, whenever this moves back and forth, that changes the cam. So that changes your timing. This is our cold start piston, but like I said before, we don't have the solenoid, so really this is more just a spacer than anything. It's not solving any practical use because there's no solenoid in here to open and close to let fluid go through to activate this piston. So it's more one of these, it's part of the pump. It's just there to make sure that everything is where it needs to be and to make sure nothing leaks. Let's just get tightened down. Got our bottom plug here, brand new O-ring, a little bit of grease. So here's our cold start plug, goes where the cold start solenoid would go if we had one. I don't really know what the ratio is of DB4s and DB2s that have cold starts to ones that don't. I know we see, you know, a variety of some do, some don't, but I can't really say that there's more of one than another. This is the old style, so there's two different styles. This one here has steps on it for O-rings. The other style just has a chamfered edge or a tapered edge for a taller O-ring. So it's one of those things that you just gotta see what you got and put the correct O-rings back in it. Like I mentioned before, this the light load orifice did not have the correct O-ring in it, which I will show you here in a second. Compared to what it should have had. Okay, O-ring is down in there. This is my servo. Goes inside the middle of the piston. That's nice and free. Grease on this stuff. Okay. Spin that in, spin to win. Whenever I pulled this, this orifice out of this hole, it had originally this little red O-ring, which for this style, the old style, what it actually needs is this black O-ring, which the other kit was an aftermarket, so they're different colors regardless. You can just kind of see the black O-ring is probably another half as thick as the red O-ring, and the diameters are different. The inner diameters are different. So that's why you have to kind of have to know what you need in your pumps, because there's the little things that, so there's a chance that that orifice might not have been sealing on the bottom. So it might have been causing issues that were harder to notice. Let's tighten down. Now we can put our cap on this. Okay, so now our whole advance is put together. We had our cold start piston, advance piston, servo piston that's in the middle, and then we had our speed, our speed advance spring, our light load assembly, which has your light load piston and then your light load spring with your adjuster on top of that. So, you know, there's quite a few parts right there. Whole purpose of this torque screw here is to limit your fuel at your full load torque setting, whatever you want to call it. So this one, normally my main fuel, it needs 81 to 82 cc's, but at my full load fuel or torque setting, it only needs, I think, 66. So, you know, that cuts it back by a good 15 cc's, which a lot has to do with emissions. They probably just determined that it didn't need that much fuel. Torque screw, this here is our gov'na spring, light load capsule, light load spring, and then a spacer right there, which the spacer is just mainly for your throttle position. Have our guide stud with a rubberized washer. Have our throttle lever here with a brand new O-ring. It's been greased up. needs to go on the right side according to my test plan. And one thing that he had also expressed to Kurt is that they felt like they couldn't get any RPMs out of this thing. Well, from what I can kind of see right here, it's a little early to tell because I'll be able to know more on the test stand, but that does not have a whole lot of spring pressure on it. So I'm assuming, I'm not going to mess with anything until I get it on the stand. I'm assuming that that is going to cut out way too early. So for some reason, that is screwed in too far. I don't know why it is adjusted that way, but I think that is going to be needed to be adjusted. But we will check that on the test stand. And that's something that then I can make note of to say, hey, you know, you needed, let's say, okay, this one high idle's at 2300. So you needed 2300 RPMs max. Well, you were only getting 2000. So that definitely affects performance, especially on a crawler. Get our retaining clip in there. Yeah, see that ain't much pressure at all. Normally, I imagine that's going to have to come forward. So right now it's set straight up and down here. I imagine it's going to have to be probably closer to there. So we're going to move it. I'm assuming, you know, a good a quarter of an inch. We'll make sure on the stand. But yeah, that just feels real weak. And I think that the spring is probably correct. I just don't think they have it adjusted right. This here is just a plug. So we got our shut-off solenoid here. I just put 2 new grommets on here, so we're going to push those down. Have his original top cover. I just cleaned it up. That goes in. We have our plastic insulators here, so that way it doesn't ground out on the top cover, or it doesn't short out, let's put it that way. Because technically it grounds out on the top cover, but the ground has to be there, not the power side. Okay, so now that is all put back together. We got new nuts on there, new grommets on the solenoid so it shouldn't leak. Our low idle screw. It's screwed into the top cover here. I'm gonna have to just preset for now. I'll set that while it's on the test stand. Put our O-ring. I said he did not have this return connector in here before. I'm assuming it's still connected to his return line. Spins. So now I got one last thing left to do, and that is to stamp my serial number in here. Okay, so we now have a completely rebuilt pump. Get this pulled off. I'll put my gear on the front so I can run it on the stand. I'll put this on the stand and then we'll run this off and see what all needs to be fixed. Okay, so got everything hooked up here. Got my inlet, fuel going in, transfer pressure, hooked to a gauge down here on the bottom here. Got my gauge. Return, that's for my solenoid. And then I got my advanced gauge over here. So everything's hooked up. It does pump. I don't see any leaks. So at least functions as it is right now, but we will see where we're at on fuel and RPMs and all that good stuff. We're going to get after it, and definitely curious on if I'm going to have to adjust that. I have a feeling I will. I'm just bleeding the air out of this. Zero out my advanced gauge here. Okay, fine. Yeah, it's cutting out way too early. So we're about 200 RPMs off of engine speed, so it's definitely not set right. Transfer pressure is a little low. I gotta adjust that right off the start. No, now we're the transfer pressure. I'm concerned that my fuel is going to be too high. That's not too bad. It's a little high, but we're not crazy here. Looks fine. Definitely at the top of where I'd want to be, but I'd rather be a little high than too low. Check our advance, make sure this is working. Yeah, even our advance ain't working right. It's coming in too early. So this thing here just was not set correctly. Which part of it could be because we put that reman housing and piston in there. So everything's a lot tighter. So there isn't as much bleed by. So that's why our advance could be coming in earlier. Because everything is actually tight. Otherwise, it just goes around the piston. Gives you more return. Bleed the air out. Every time I open this up, I have to bleed the air out of it. Okay, we're actually, that's perfect. I got lucky on that one. Check our solenoid, make sure it's shutting everything off. So basically, I disconnected the power to the solenoid so it's acting like I turned the key off. And it shuts it off. We're getting plenty of cranking fuel, so that's good. So that means it'll start good. Yeah, that's real good starting fuel. Set our high idle. Idle set now. Now we're checking governor cutoff. So basically I'm making sure that the weights open up all the way and push the metering valve towards shutoff. Which that does, it shuts off good. So now as I slow down, the weights are gonna collapse back in on themselves. Bringing that back down to full fuel. So now is where I'm gonna set my corkscrew. Shut off again, just because that's what it wants us to do. That shuts off fine. Adjust my advance some more. We're getting it. It just takes some fine tuning. Okay, so I checked, I just did a kind of a preliminary check on my light load, and it was going too slow, so I got back this other adjuster out too. Hopefully that'll be good now. You might be able to. So basically, as I pull this lever back, this advance gauge is going to come up. And this is simulating like a low load or a no load situation. Bottom. Now we'll check it up at the top. That is in spec. Yeah, our low idle needs turned into, but that's no real surprise. Yeah, I gotta screw in both of the screws. I could probably. Yep, perfect. Okay, so it definitely had some issues. The biggest thing was we weren't getting enough RPMs because our high idle screw was not set correctly, and our advance was off, which that could be contributed to changing out the housing to one that's actually tight, not worn out. So, but between the two things, it was very easily fixed. Let's put it that way. Didn't really have any issues, but it definitely needed readjusted. Overall, he should be pretty happy with this once he's done with it. So basically now all I gotta do is take this off. Now I gotta air time it and put my timing mark on the flange, and then after that, we'll be good to go. Back in the room, still got my gear on there. This is my degree wheel, has 0 through 360. This particular pump needs 193 degrees, which is just some arbitrary degree that they decided upon. I don't know how they decide that, but that's just what's on my test spec. One cylinder is 5 o'clock, so I have to hook my air pressure to a specific cylinder, which would be number 1 cylinder in this case. Hook my air to it. Just gotta spin this around until it locks up. Sometimes it takes, there we go. It's thinking about it. It's thinking about locking up. Okay, now I'll stick my tool on here. I like to go around it a few times just to make sure that it is the accurate timing mark. Again, repeatability is accuracy. It seems like it's stopping in the same spot. Normally I just like to make a faint line to start. Yep, that's spot on. I'm spot on my degrees. So now I just got to make a mark with my pick here. Perfect. So now, good thing there wasn't nothing in that. So now he has, you can just see my timing line there. So now he has to line that up with the mark or whatever he has on his timing cover, and then the pump will be in time with his engine. That is how you time a DB4, which like I said, I would say 90% of all DB4s are timed like that. Not very often do they have an internal timing mark, and there's times even if they have an internal timing mark, they still want you to air time it as well. So it's just one of those things, if you're doing a DB4, you almost always got to air time it. And you really need to do that after you've ran it, because changing your roller to roller dimension will change your timing, because it changes where it hits on the cam. And this is also kind of a double check, because like let's say I didn't line up the dot on the rotor with the dot on the drive shaft. Let's say they were 180 out. Now instead of it locking up here, it'd be locking up over here in no man's land. So it's just kind of a double check to say, oh yes, it is built correctly because it timed correctly. So just one of them things, you know. You gotta make sure everything is correct from start to finish. So now I just got to put this locking plate in, which I showed whenever we tore it apart. That locks down the end cone. And like I said, that's where I read my transfer pressure out of. That looks good. Make sure that's tight. Put the cap in there. Again, just tamper-proof cap. New caps here. Doesn't leak everywhere inside the box. Tap that down. And it makes it so that way they don't get paint in there. Our side cover back on it. See if I can get these rivets out without them breaking. Most time they break off. There's always one that normally doesn't want to come out. It just breaks off. Luckily this one don't seem to be very hard. Some of these things drill right out and some of them are hard as rocks. Can't drill bit hardly won't even touch it. So we are now ready for paint. So I gotta get back with Kurt, but overall this pump is ready to go back. So basically tore it apart, found that it did have some fuel contamination in it. Not a lot, but some. Everything was still free, but it was definitely a little nasty on the inside. The housing and piston were worn out, so that needed replaced. Our oil seal was rolled, which was why he was getting oil at the weep hole. So we definitely found those issues there. Rebuilt the pump. He complained about RPM issues, which we learned that on the stand that it was about a couple hundred RPMs off. So he's definitely going to be getting some more RPMs, and this even feels more normal because, like I said, whenever I built it before, it just seemed super loose. So that was good. Definitely found issues. Had to reset the advance because it was coming in too early. So overall, it definitely needed repaired. You know, I always tell people we don't rebuild pumps. We repair pumps by rebuilding them. So that's the whole name of the game. Repairing pumps so that then the customer can get their pump or turbo back, injectors back, and it actually fixes their problem that they're having. Guaranteed sometimes it's not the pump's fault or the turbo's fault. It has to do something with their engine. But regardless, you always hope that whenever the customer gets their product back, that they're happy with it and it actually fixes their problem. So hopefully whenever he gets this back on, it'll run perfect. I hope you guys enjoyed it. Something a little different, a DB4, we've never done one before. So this is Corey here, and I'm going to sign out and give it back to Kurt.
There she is in all of her glory. A far cry from what it looked like when it come in. Corey has whipped this back into perfect functioning order. What did we find? You probably saw it, but if you skipped forward, looks like Ray Charles put the seal in it, didn't use a seal installer tool, knocked the lip right off of it, and she was leaking oil. So I don't know who did the prior rebuild, and you'll never hear us knock anybody, but it looked a little bit like amateur hour. They rolled the seal, complete workmanship issue, rolled that right over, and then don't know how they calibrated, likely didn't, right? Could have just been what we call a tailgate rebuild, and they moved some of the magic screws and didn't get them put back proper. Really, the pump was in pretty good condition, was functioning, just not properly. The housing and piston were wore out in the bore. I'm sure Corey spoke about that. We machine and re-sleeve that housing. Standard overhaul components, blades, liner, gasket kit, delivery valve, some of Master Corey's time, and a paint job, and we are ready to rock. We did confirm that the throttle lever and the timing window were correct for this application. Really, most of the assembly looked proper. I think Corey said he found one incorrect O-ring, but everything was in it and everything was reassembled correctly. They got really close to quality repair, but they missed it just by a little bit, and a little bit is a mile when it comes to injection pumps. So the million-dollar question, as per usual, what did it cost, right? We went over the parts. We had about 4 hours of labor. This pump in this situation at today's rate checked in at $686.42. So $700 complete pump overhaul. Your results can and will likely vary. Just throwing out there a frame of reference. That's what this one cost. That's as of today. A lot of people want us to quote their rebuild in advance, and it's basically impossible to do. It's kind of like calling the body shop and telling them you hit a deer and wanting to know how much it is to fix your car, right? You don't have any idea until you get into it. We can give you a range. We can give you a ballpark average repair and return cost. We'll tell you that when we quote you. If yours is a boat anchor, if it's been sitting on the bottom of the ocean, if the shmoo has hardened, If it's busted in half, if you took it off with a torch, who knows? Could be unrepairable, could be totaled. I will tell you that we are fair, we are honest, we are capable, and we're not going to rip you off. If yours is all chooched up, we've got the stuff to fix it, right? So we've got complete pumps and housings and cores and new parts and access and friends. We've got the connections. So if you find yourself in need of some diesel engine components, please don't hesitate to reach out and let us know. We would love an opportunity to earn your business. We are diesel engine component repair and distribution, primarily of the fuel injection and turbocharger variety, but we're into a little bit of everything: diesel engine, overhaul kits and water pumps, starters, alternators, after treatment and emissions, sensors and whatnot. If it's on a diesel engine, from lawnmower to locomotive, we're here trying to help you out. If you are curious whether or not Corey was able to make this pump function again, please go over to CNC, watch the boys reinstall this pump, and let's find out if we were able to save the day. If you need something, hit us up and let us know. If you don't need a pump, if you don't need a turbo, we got a swag shop. You can be a schmoo fighter too, and we've got some other goodies in there for you. So that's it for now. Thanks for watching. If this was a Beatles album, which album would it be?
Only one right answer.
Wrong answers only.
Yeah.